Chairman of HAZOP, 10 common oversights and their consequences during the workshop process. 1. Failing to clearly define scope and terms of reference. Oversight. Starting the study without a firm agreement on what systems, PNIDs, and boundaries are included. This often happens when the chairman assumes everyone has the same understanding without formally confirming or documenting it. It can also result from inadequate alignment with project management before the workshop. Consequence. The team may spend time analyzing irrelevant systems while overlooking critical sections, leaving gaps in hazard identification. This undermines the completeness of the HAZOP and can lead to costly rework or, worse, undetected hazards making it into construction or operation. It also causes frustration among team members who later realize their efforts were misdirected. 2. Poor management of team dynamics. Oversight. Allowing certain personalities to dominate discussion while quieter or junior members contribute little or nothing. The chairman may fail to actively facilitate balance in input, especially in mixed discipline groups. Without structured turn-taking or directed questioning, contributions become uneven. Consequence. Valuable operational experience or discipline-specific knowledge may be lost because it was never voiced. This creates blind spots in hazard identification and leads to recommendations that are incomplete or biased toward one discipline's perspective. It can also lower morale as less vocal members feel sidelined. 3. Rushing through process elements. Oversight. Attempting to cover too many PNIDs in too little time to meet an arbitrary schedule. The chairman may prioritize speed over quality, often under project pressure. This results in superficial treatment of deviations and inadequate exploration of credible causes. Consequence. Critical hazards may be missed entirely, and operability issues may remain undiscovered until commissioning or operation. Once in the field, these oversights can cause operational delays, safety incidents, or expensive modifications. It also damages the credibility of the HAZOP process in the eyes of participants. Not enforcing credibility. Filtering for causes. Oversight, recording every suggested cause, no matter how improbable, without filtering for realistic, credible scenarios. This usually stems from the chairman's reluctance to discourage input, but without clear filtering criteria. Consequence. The log sheets become cluttered with low-value entries, making it harder for the project team to focus on genuine risks. This increases follow-up workload unnecessarily and dilutes attention from critical issues. Over time, this practice can cause stakeholders to lose confidence in the relevance of HAZOP findings. 5. Allowing scope creep during sessions. Oversight. Permitting discussions to drift into unrelated technical debates, design philosophy arguments, or problem-solving beyond the agreed study scope. The chairman may fail to recognize when the conversation has moved away from the structured deviation, cause, consequence, safeguard, action fence. Valuable workshop time is consumed by topics that should be handled outside the HAZOP. This delays completion, causes frustration, and may result in incomplete coverage of process elements. Scope creep also weakens discipline in the method, making the study less systematic. Inadequate control of session fatigue. Oversight. Scheduling long, uninterrupted sessions or consecutive full days without considering cognitive load. The chairman may ignore signs of reduced focus, such as repetition in discussion or slower response times from the team. Consequence. Fatigue leads to reduced concentration, making it easier to miss hazards or accept weak safeguards without challenge. The final sections of the study may be of noticeably lower quality than the early ones. This unevenness can leave risk gaps exactly where attention is needed most, often in complex or late-reviewed sections. 7. Failure to clarify design intent before applying guide words. Oversight. Starting guide word analysis without first ensuring everyone understands the design purpose, operating envelope, and functional objectives of the process element. This can happen when the chairman assumes the drawings alone are self-explanatory. Consequence. Deviations may be incorrectly framed or misinterpreted, leading to inaccurate identification of causes or consequences. Safeguards may be mismatched to hazards, and recommendations may be irrelevant or ineffective. This undermines the technical integrity of the entire session. 8. Insufficient pre-study preparation. Oversight. Coming into the workshop without having reviewed PNIDs, cause and effect charts, previous HAZOP reports, and vendor data. The chairman may rely on ad hoc explanations from team members during the study instead of leading with informed context. Consequence: sessions progress more slowly, with unnecessary time spent on clarifying basic information. This erodes the chairman's authority and disrupts the flow of analysis. Poor preparation also increases the likelihood of overlooking areas where prior findings or changes affect current hazards. 9. Weak action formulation. Discipline oversight, allowing vague, incomplete, or non-actionable recommendations to be recorded. The chairman may not press for clarity on who will own the action, what exactly must be done, or how effectiveness will be verified. Consequence: actions may stall after the workshop because they lack specificity or measurable deliverables. Project teams may misinterpret the intent, leading to inadequate or misaligned responses. In critical cases, hazards may remain unaddressed despite a recommendation being on record. For Plan 10, not maintaining momentum in follow-up oversight, treating the issuance of the HAZOP report as the endpoint without ensuring a follow-up process is in place to track and close recommendations. The chairman may not verify that action tracking ownership is assigned before disbanding the team. Consequence: important safety improvements and design corrections may be delayed or never implemented. This undermines the credibility of the HAZOP process and leaves the facility exposed to avoidable risks. In regulated environments, it can also lead to compliance failures during audits or inspections. Secretary Scribe of HAZOP, 10 common oversights and their consequences during the workshop process. 1. Incomplete or inaccurate recording of discussions. Oversight: failing to capture every credible deviation, cause, consequence, safeguard, and action discussed by the team. This can happen due to distraction, typing delays, or over-reliance on memory to fill gaps later. Consequence: missing details weakens the audit trail, making it impossible to justify why certain decisions were made. If challenged after an incident, the record may not prove that hazards were considered, exposing the organization to legal or regulatory risk. 2. Poor clarity and consistency in log sheet entries. Oversight: using inconsistent terminology, abbreviations, or vague language across entries. Different PNIDs may contain similar deviations described in completely different ways. Consequence: inconsistency confuses follow-up teams and makes cross-referencing between sections difficult. It increases the likelihood of misinterpretation, potentially leading to incomplete or incorrect mitigation measures. 3. Failure to confirm accuracy with the team before finalizing entries. Oversight: recording the secretary's interpretation of what was said instead of confirming the exact wording with the group. This can occur when the pace of discussion is fast and the scribe hesitates to interrupt. Consequence: recommendations or causes may be altered in meaning, leading to incorrect implementation. In serious cases, a safeguard could be misrepresented as adequate when it was not, leaving hazards unaddressed. 4. Not tracking changes to process parameters or guide words. Oversight: forgetting to update the master list when the team decides to add or remove guide words or parameters mid-study. Consequence: the final report may falsely state that all elements were analyzed with a certain set of guide words, when in fact the applied list was different. This compromises audit credibility and can mislead future reviewers. 5. Losing control of document version management. Oversight: recording notes against outdated PNIDs, vendor packages, or cause and effect charts without confirming the latest revision. Consequence: findings may be tied to obsolete designs, resulting in recommendations that are irrelevant or impossible to apply. This wastes project resources and may allow hazards in the latest design to go unidentified. 6. Recording non-credible causes or redundant information. Oversight: logging every brainstormed idea without filtering for credibility or relevance as agreed by the team. Consequence: action lists become cluttered with low priority or unrealistic items, slowing down the post-HAZOP follow-up process. It can cause stakeholders to question the value of the entire study. 7. Failure to maintain the master set of marked up PNIDs. Oversight: not consistently marking each studied process element on the master drawings or doing so inaccurately. Consequence: it becomes unclear which elements were reviewed, making it easy to overlook areas in later verification. This can result in incomplete hazard coverage and potential duplication of work in future reviews. 8. Overlooking attendance and documentation records, oversight, forgetting to log who attended each session, what documents were referenced, and what revisions were used. Consequence: if the study is reviewed months or years later, there may be no way to verify that the right expertise was present or that correct documents were used. This can lead to questions over the legitimacy of the findings. 9. Not capturing the rationale for non-recommendations. Oversight: when the team decides no action is needed for a deviation, failing to note why it was considered acceptable. Consequence: later readers may assume the issue was missed rather than consciously accepted. This can cause unnecessary reanalysis or, worse, a mistaken belief that a hazard was never addressed. 10. Slow or disorganized real-time data entry oversight. Falling behind the discussion due to typing delays, poor familiarity with the log sheet format, or inefficient note-taking methods. Consequence: key points may be lost or oversimplified, and the chairman may have to pause repeatedly to let the scribe catch up, slowing the entire workshop. This disrupts the momentum and reduces team engagement. Process Design Engineer: 10 common oversights and their consequences during the workshop process. 1. Not providing clear design and before analysis oversight. Failing to verbally explain the purpose, operating philosophy, and design limits of the process element before the team starts applying guide words. Often this occurs because the engineer assumes everyone can interpret the P&ID without additional context. The absence of explanation leaves each participant relying on their own interpretation, which may differ significantly from the original design basis. Consequence: misunderstanding the intended function can lead the team to identify irrelevant deviations, focus on non-issues, or overlook real hazards. Safeguards may be assessed against the wrong operating conditions, and recommendations may target non-critical risks while missing high-priority ones. This undermines the accuracy of the workshop outputs and reduces the study's value as a hazard identification tool. 2. Overlooking integration points with other systems. Oversight: concentrating solely on the defined process element and neglecting its interdependencies with upstream, downstream, or utility systems. This is common when trying to stay within scope, but doing so without cross-boundary checks. Overlooking tie-ins, shared control systems, or common utility supplies can cause blind spots in the analysis. Consequence: hazards that arise from system interactions, such as utility loss, backflow, or cascade failures, remain undiscovered. For example, a fault in an upstream system could create unexpected conditions in the reviewed element that are never considered. Such oversights can lead to incomplete safeguard strategies and missed opportunities for system-wide risk reduction. 3. Using outdated or incomplete design data. Oversight: presenting P&IDs, data sheets, or cause and effect diagrams that are not at the latest revision or lacking key details such as vendor equipment data, line sizing, or specification references. This often results from inadequate document control before the workshop. Without accurate, up-to-date information, the team bases its work on assumptions. Consequence: the recommendations produced may not align with the real design, meaning corrective actions may be invalid or irrelevant. This creates wasted effort in implementing changes that do not address actual risks. More critically, genuine hazards in the latest design iteration may be left unassessed, exposing the facility to avoidable danger. 4. Failing to highlight known design limitations. Oversight: not openly disclosing areas where the design includes compromises, such as reduced redundancy, undersized equipment, or relaxed specifications, due to cost or space constraints. The engineer may avoid raising these points to prevent criticism or project delays. This prevents the team from focusing on known weak spots. Consequence: the HAZOP may proceed under the false assumption that all elements meet ideal standards. As a result, hazards associated with the known limitations may be underestimated or ignored entirely. This allows higher than expected risk levels to persist into operation, where they may manifest as performance or safety issues. 5. Insufficient engagement in brainstorming. Oversight: participating passively and speaking only when prompted, rather than actively contributing causes, consequences, or safeguards based on disciplined knowledge. This often happens when the engineer is multitasking or distracted during the session. A lack of proactive input diminishes the richness of the team's analysis. Consequence: Discipline-specific insights, particularly those involving subtle process nuances, may never be voiced. Without these inputs, the hazard review lacks depth, increasing the chance of missing critical deviations or underestimating risks. This compromises the completeness of the final recommendations and weakens the technical quality of the HAZOP. Overcomplicating technical explanations. Oversight, providing highly technical, jargon-heavy responses without considering the mixed backgrounds of team members. This can overwhelm non-specialists or cause them to disengage from the discussion entirely. The lack of simplified, clear explanations prevents shared understanding. Consequence. Key hazards or safeguard limitations may be misunderstood or incorrectly documented by the scribe. Other participants may remain silent rather than ask for clarification, leading to group decisions based on partial understanding. This undermines the collaborative nature of the HAZOP and reduces the accuracy of recorded outcomes. 7. Neglecting to validate safeguard adequacy. Oversight. Accepting the existence of a safeguard without verifying whether it is adequately designed, located, or maintained to address the hazard. This can result from time pressure or a reluctance to challenge existing designs. In doing so, safeguards are assumed to be effective without proof. Consequence. Weak or incomplete protections remain in place, giving a false sense of security. For example, relief valve may be incorrectly sized or a trip point may not align with process dynamics. If such issues remain undiscovered, they can lead to hazardous events during operation that the HAZOP process should have prevented. 8. Not linking recommendations to practical implementation. Oversight. Suggesting corrective actions that, while technically sound, ignore constraints like constructability, cost, lead times, or available shutdown opportunities. This can happen when the engineer focuses on theoretical fixes without considering real-world feasibility. Consequence. Project teams may later reject or postpone these recommendations due to impracticality, leaving the underlying hazard unresolved. This also wastes the effort spent generating and reviewing such recommendations and can erode trust in the HAZOP's ability to produce implementable solutions. 9. Failure to bring relevant design references to the workshop. Oversight. Arriving at the session without essential supporting materials such as detailed specifications, vendor manuals, or calculation reports. This forces the team to rely on memory or incomplete data to assess deviations. Key details may be unavailable when most needed. Consequence, the analysis may be delayed, deferred, or proceed with incorrect assumptions, reducing the quality of hazard identification. Some decisions may require revisiting later, leading to inefficiency and the potential for missed deadlines in the project schedule. 10. Defensiveness when design is challenged. Oversight, responding to hazard identification as personal criticism of the design work and resisting open discussion of possible weaknesses. This can create tension in the room and discourage collaborative problem solving. Consequence. Team members may feel hesitant to voice concerns, especially if they contradict the design engineer's position. This can result in critical hazards being downplayed or ignored entirely, reducing the integrity of the hazard review and leaving the facility exposed to preventable risks. Control and instrumentation engineer 10 common oversights and their consequences during the workshop process. 1. Not explaining control philosophy clearly, oversight. Failing to describe the control strategy, interlocks, trips, and alarm logic for the process element under review. This often occurs when assuming the P&IDs and cause and effect charts are self-explanatory to all team members. Without this explanation, the team lacks a shared understanding of how the system is intended to respond under abnormal conditions. Consequence. Hazards related to incorrect or inadequate control system responses may be overlooked. The team might incorrectly assume that certain protections exist or function in a specific way, leading to misplaced confidence in safeguards and a false sense of operational security. 2. Using outdated or unverified logic diagrams. Oversight, presenting logic diagrams, alarm lists, or cause and effect charts that are not at the latest approved revision or have not been cross-checked against the current P&IDs. This can happen due to poor document control or last-minute changes not being reflected in the shared materials. Consequence, recommendations may be based on incorrect system functionality, resulting in ineffective or misdirected actions. Real hazards present in the updated design could remain unidentified, and changes implemented later may inadvertently introduce new risks that were never assessed. 3. Overlooking human-machine interface, HMI limitations. Oversight. Not considering how operators interact with the control system during abnormal situations, such as the clarity of alarm messages or the grouping of controls on the HMI. These human factors can significantly affect response times. Consequence, the HAZOP may miss hazards arising from delayed or incorrect operator responses due to poor interface design. This can result in situations where technical safeguards exist but cannot be effectively acted upon in real time, increasing operational vulnerability. 4. Not assessing alarm management practices. Oversight. Focusing solely on whether alarms exist without considering alarm prioritization, nuisance frequency, or whether alarms are actionable within the available operator response time. Consequence. Critical alarms may be ignored or lost in a flood of less important notifications, causing slow or incorrect responses to real hazards. This can lead to incidents that could have been prevented through better alarm configuration and rationalization. 5. Failing to validate instrumentation redundancy and reliability oversight. Accepting instrumentation as adequate without verifying redundancy, fail-safe design, or maintenance testing provisions. This often happens when assuming standard designs automatically meet reliability needs. Consequence. Single-point failures may be left unaddressed, allowing a hazard to progress undetected if a critical instrument fails. This increases the likelihood of hazardous events during both normal operation and emergency conditions. Neglecting to consider instrument location and accessibility. Oversight. Overlooking whether field instruments, junction boxes, or control panels are physically accessible for operation and maintenance, or whether they are protected from environmental hazards. Consequence. Instruments may be difficult to reach in emergencies or may degrade faster in adverse conditions, reducing reliability. This can result in safeguard failure at the exact moment it is needed most, compromising both safety and operability. 7. Underestimating the impact of instrument failure modes. Oversight. Not fully analyzing how the control system behaves when an instrument fails, whether it fails safe, fails dangerous, or causes spurious trips. This lack of detail can lead to false assumptions about system safety. Consequence. Failures may create hidden vulnerabilities, such as an emergency shutdown system that fails to trip when required or trips unnecessarily, causing costly process interruptions and potentially creating secondary hazards. 8. Failing to cross-check safeguards against process dynamics, oversight. Accepting a safeguard, e.g. high-pressure trip, without confirming it will activate in time based on process dynamics and instrumentation response times. This can occur if the engineer relies solely on set points without time delay analysis. Consequence. Protective actions may occur too late to prevent the hazard, allowing equipment damage or releases to occur despite the presence of safeguards. This undermines confidence in the control system's ability to mitigate risks. 9. Not linking recommendations to testing and maintenance requirements. Oversight. Proposing instrumentation changes without specifying how they will be tested, calibrated, and maintained over the life cycle of the facility. Without this consideration, changes may be implemented without proper support procedures. Consequence. Safeguards may degrade over time or be bypassed without notice, creating a false impression of ongoing protection. This can result in long-term operational risk that remains invisible until an incident occurs.
10.
Defensiveness. When control system adequacy is questioned. Oversight. Reacting negatively when other team members highlight possible weaknesses in the control system design. This defensiveness can stem from a sense of ownership or pride in the system architecture. Consequence. Open discussion is stifled, and potential hazards may go unchallenged. The team may avoid probing certain aspects of the control system to avoid conflict, leading to gaps in hazard identification and reduced effectiveness of the HAZOP. Operations Specialist 10 Common Oversights and Their Consequences During the Workshop Process. 1. Not providing realistic operational context oversight, failing to describe how the process is actually operated during startup, shutdown, normal operation, and upset conditions. This often happens when assuming the team understands how it's done in the field. Without these insights, the analysis stays overly theoretical. Consequence: hazards tied to real-world practices, such as temporary workarounds, non-standard sequences, or informal communication methods, may be missed. As a result, HAZOP findings may not fully address the actual ways in which risk manifests during operations. 2. Overlooking non-routine and infrequent operations. Oversight: concentrating discussion only on steady-state operation and neglecting to raise hazards associated with infrequent activities like equipment switchover, maintenance isolations, or chemical changeovers. Consequence: deviations that occur during rare but high-risk operations remain unexamined. This leaves potential vulnerabilities unmitigated, often in scenarios where safeguards are weakest and operators are most exposed. 3. Not highlighting historical operational problems. Oversight: failing to share relevant past incidents, near misses, or recurring plant issues due to lack of preparation or assumptions that the design has fixed it. Consequence: the team misses opportunities to address proven weaknesses. Hazards with a track record of occurrence may be overlooked, allowing history to repeat itself, possibly with more severe consequences. 4. Ignoring human factors and operator workload oversight. Not pointing out instances where alarm floods, poor panel layouts, or physically demanding manual tasks make correct operator response difficult under time pressure. Consequence: hazards linked to human limitations remain unchallenged, even though the technical safeguard may be present. In reality, an operator might not be able to take the intended action quickly or accurately enough to prevent escalation. 5. Failing to validate practicality of recommendations. Oversight: remaining silent when the team proposes changes that are difficult to implement in day-to-day operations, such as overly complex procedures or inaccessible equipment. Consequence: recommendations may be accepted and implemented, but prove impractical, leading operators to bypass or ignore them. This undermines the intended safety improvements and can breed a culture of workarounds. 6. Not representing the full range of operational modes. Oversight: focusing only on the mode they are most familiar with, e.g. normal production, without considering alternate modes like startup, partial loading, emergency shutdown, or commissioning. Consequence: hazards specific to less common operating modes may be left out of the study. These modes often present unique vulnerabilities that can lead to high-consequence events if not addressed. 7. Withholding feedback on accessibility and maintainability. Oversight: not raising concerns about physical access to valves, instruments, or equipment for routine and emergency tasks. This can occur if the operator assumes design engineers are already aware. Consequence: changes may be implemented that create ergonomic or access hazards, making certain emergency actions physically difficult or unsafe. These problems often surface only during actual emergencies, when response time is critical. 8. Underestimating the impact of operator training and competence oversight, not discussing how differences in skill levels, experience, or training among operators could influence the ability to respond to deviations. Consequence: recommendations may assume a higher level of competence or knowledge than exists in reality, creating a dangerous mismatch between safeguard design and operator capability. 9. Not challenging assumptions about procedural compliance. Oversight: accepting that written procedures will always be followed exactly, without mentioning instances where time pressure, staffing issues, or routine familiarity lead to deviations. Consequence: hazards arising from procedural noncompliance remain hidden, resulting in a safety management gap between the documented process and actual behavior in the field. 10. Defensiveness about operational practices. Oversight: reacting protectively when others question current operating methods, leading to reduced transparency about practices that may be less than ideal. Consequence: the team may avoid discussing operational weaknesses for fear of confrontation, allowing known risks to persist unaddressed. This can seriously undermine the credibility and completeness of the HAZOP findings. Project engineer 10 common oversights and their consequences during the workshop process. 1. Not providing a complete overview of project scope oversight, failing to clearly explain the overall project boundaries, objectives, and integration points before the HAZOP begins. This often happens when assuming the team already knows the project background. Without this framing, members lack a shared understanding of the context for each design element. Consequence: the team may misinterpret the design intent or overlook hazards related to interface points between new and existing systems. This can result in incomplete hazard coverage and create costly surprises during construction or commissioning. 2. Insufficient coordination of document readiness. Oversight: not ensuring all required drawings, datasheets, and vendor information are current, approved, and available before the HAZOP sessions. Delays in document readiness often disrupt the workshop flow. Consequence: the study may be forced to proceed with outdated or incomplete information, leading to incorrect recommendations or deferred decisions. This wastes valuable workshop time and can reduce the quality of the hazard analysis. 3. Not identifying key stakeholders for participation. Oversight: overlooking critical team members such as vendor specialists, commissioning staff, or operations representatives when finalizing the HAZOP attendance list. Consequence: essential expertise may be missing during critical discussions, leading to assumptions that later prove wrong. This can result in hazards being overlooked or recommendations being impractical for field implementation. 4. Underestimating the impact of schedule constraints. Oversight: pushing for accelerated HAZOP completion to meet project deadlines without considering the complexity of the systems under review. This can create pressure on the chairman to rush through analysis. Consequence: hazards may be missed or inadequately explored, resulting in an incomplete safety review. In the long term, rushed sessions can cause expensive rework or delays when issues surface during commissioning or operation. 5. Not tracking action items post-HAZOP oversight, treating the HAZOP report as the final deliverable, and failing to implement a robust follow-up process to ensure recommendations are addressed. Consequence: important hazard mitigation measures remain unresolved, potentially allowing identified risks to persist into operation. This undermines the credibility of the entire HAZOP process and can result in regulatory noncompliance. 6. Overlooking vendor package integration risks. Oversight: failing to assess how vendor-supplied systems fit into the overall process and control strategy during the HAZOP. This often occurs when vendor equipment is treated as a black box. Consequence: hazards at the interface between vendor equipment and the main plant may go unidentified. This can lead to operational conflicts, safety risks, or the need for costly design modifications late in the project. 7. Not communicating design changes promptly. Oversight: delaying updates to the HAZOP team about design modifications that occurred during or after the study. This can cause misalignment between what was reviewed and what will be built. Consequence: recommendations may no longer be relevant, or new hazards introduced by design changes may remain unaddressed. This creates a false sense of security in the completeness of the hazard review. 8. Failing to bridge between technical and project priorities. Oversight: not facilitating discussion on how hazard mitigation measures can be integrated into the project's cost, schedule, and procurement constraints. Consequence: recommendations may be technically sound but infeasible within the project constraints, resulting in partial or no implementation. This can leave critical risks unresolved and erode stakeholder trust. 9. Insufficient preparation for HAZOP chair and team oversight, not providing the chairman and participants with pre-read materials, project context, and relevant design history before the sessions. Consequence: time is wasted in the workshop explaining basic information, slowing the pace, and reducing the depth of analysis. The overall effectiveness of the HAZOP is diminished. 10. Defensiveness over project decisions. Oversight: responding negatively when design or project decisions are challenged in the workshop, leading to reluctance in discussing trade-offs or alternative approaches. Consequence: team members may avoid questioning project assumptions, allowing suboptimal or unsafe design decisions to remain unchallenged. This weakens the quality and completeness of the hazard analysis. Safety HSE Specialist: 10 common oversights and their consequences during the workshop process. 1. Not framing hazards in the context of regulations and standards. Oversight: failing to relate identified hazards to specific regulatory requirements, corporate standards, or industry codes. This often happens when discussions remain general instead of anchored to compliance obligations. Consequence: recommendations may not align with legal or corporate compliance needs, leading to potential regulatory breaches. This can also result in rework if regulators require changes later, increasing project cost and delay. 2. Overlooking environmental impact scenarios. Oversight: focusing primarily on personnel safety and neglecting to address potential environmental consequences, such as emissions, effluent, spills, or long-term contamination. Consequence: hazards with significant environmental consequences may remain unmitigated. This can result in environmental incidents, reputational damage, and substantial fines if issues emerge during operation. 3. Not considering emergency response feasibility. Oversight: identifying hazards without evaluating whether current emergency response capabilities, muster points, firefighting systems, evacuation routes can effectively address them. Consequence: emergency plans may look adequate on paper but fail in practice, leaving personnel and the facility vulnerable during actual incidents. This gap may only become evident during a crisis. 4. Underestimating human factors in safety oversight. Not integrating human error potential, workload, and stress factors into hazard evaluation. This can occur when the focus remains entirely on technical safeguards. Consequence: hazards that depend on timely and accurate human intervention may be underestimated, leading to safeguards that are unreliable in real-world conditions. This can increase both the likelihood and severity of incidents. 5. Failing to challenge the adequacy of existing safeguards. Oversight: accepting safeguards as adequate without reviewing their design basis, maintenance history, and performance records. Consequence: weak, degraded, or outdated safeguards may be incorrectly assumed to be fully functional. This can allow a critical hazard to persist undetected into operation, undermining overall facility safety. 6. Not highlighting cumulative or escalation risks. Oversight: treating each hazard in isolation without assessing how multiple hazards could interact or escalate under certain conditions, e.g., fire leading to toxic release. Consequence: the team may fail to anticipate worst-case scenarios, leading to incomplete mitigation strategies. This can make emergency response planning inadequate for real high-impact events. 7. Overlooking risks from simultaneous operations. Oversight: ignoring the combined risks of multiple activities occurring at the same time, such as construction work during plant operation. Consequence: hazards unique to overlapping activities remain unidentified, potentially leading to incidents that neither activity would create in isolation. This gap can be a major source of unexpected accidents. 8. Not linking hazards to safety management system, SMS processes. Oversight: failing to ensure that identified hazards are tied to ongoing safety processes such as permit to work, training, or competency management. Consequence: even well-documented hazards may not be managed effectively after the HAZOP because they are not integrated into the facility's operational safety framework. 9. Insufficient documentation of safety justifications. Oversight: not recording why a hazard was deemed acceptable, especially if no additional safeguards are recommended. Consequence: future reviewers may assume the hazard was overlooked rather than consciously accepted, leading to duplicated effort or false assumptions about safety coverage. 10. Defensiveness. When safety culture is questioned. Oversight: reacting negatively when operational practices or cultural attitudes towards safety are challenged. This can lead to downplaying concerns about procedural noncompliance or informal workarounds. Consequence: team members may hesitate to raise sensitive safety issues, allowing cultural or behavioral risk factors to persist unaddressed, which undermines the overall safety integrity of the operation. Constructive challenge: 10 common oversights and their consequences during the workshop process. 1. Not encouraging open what-if questions. Oversight: failing to actively invite all participants to challenge assumptions by asking hypothetical what-if questions, regardless of seniority or discipline. Consequence: potential hazards remain hidden because participants self-censor. The study becomes a confirmation exercise instead of a proactive risk search, leading to blind spots in hazard identification. 2. Allowing judgmental reactions to ideas. Oversight: letting dismissive comments, sarcasm, or visible frustration occur when team members raise speculative scenarios. Consequence: Participants feel unsafe to contribute further, especially with unconventional ideas. This reduces the diversity of perspectives and may cause rare but high-impact hazards to be overlooked. 3. Failing to reinforce that no question is too basic. Oversight. Neglecting to clarify that even seemingly simple or obvious what-if questions can be valuable in uncovering oversights. Consequence. Junior or less experienced members remain silent, assuming their contributions would be redundant. This deprives the team of fresh viewpoints that may detect errors missed by seasoned personnel. 4. Not balancing technical rigor with creativity. Oversight. Overemphasizing only fully evidence-based suggestions, discouraging participants from exploring plausible but less documented scenarios. Consequence. The team may fail to anticipate novel or emergent hazards, especially those outside existing historical data. This can result in incomplete safeguard strategies. 5. Allowing dominant voices to shut down discussion. Oversight. Permitting certain individuals to overrule or talk over others when their suggestions seem unlikely or impractical. Consequence. Participants with valid but initially misunderstood concerns may withdraw entirely. This diminishes collaborative exploration and narrows the hazard review's scope. 6. Neglecting to document all credible challenges. Oversight. Skipping over what-if suggestions that seem minor at first glance and failing to record them for later review. Consequence. Early-stage ideas that might have revealed complex hazards are lost. The audit trail becomes incomplete, making it hard to prove that potential issues were considered. 7. Not providing examples of effective challenge oversight. Expecting participants to engage in constructive challenge without modeling how to phrase and explore such questions productively. Consequence. Contributions may become either overly cautious or aggressively confrontational, creating tension rather than collaboration. This undermines the quality of hazard exploration. 8. Ignoring cultural or hierarchical barriers. Oversight. Failing to recognize that in some environments, junior staff may be reluctant to challenge senior colleagues or establish design decisions. Consequence. Critical what-if scenarios go unspoken, especially if they question senior authority. This perpetuates design or procedural weaknesses through unchallenged assumptions. 9. Not closing the loop on raised challenges. Oversight. Allowing what-if questions to be raised, but not clearly addressed, resolved, or documented with rationale. Consequence. Participants may feel their contributions are ignored, reducing engagement. Unresolved issues can resurface later as unmitigated hazards during operation. 10. Overlooking the link between psychological safety and quality outcomes. Oversight. Treating constructive challenge as a soft skill rather than a critical input to hazard completeness. Consequence. Without a safe environment for questioning, the study risks becoming a compliance formality. Hazards that could have been identified through healthy debate remain undetected, potentially leading to costly or dangerous incidents. Active listening. 10 common oversights and their consequences during the workshop process. 1. Interrupting before the speaker has finished oversight. Cutting in with counterpoints, corrections, or new ideas before the current speaker has fully explained their perspective. Consequence. Important details or contextual reasoning are lost, which can lead to partial understanding of the hazard or safeguard. This increases the risk of misinterpretation and incomplete recommendations. 2. Failing to capture the nuance of the input oversight. Hearing the general point but missing the specific conditions, limitations, or examples provided by the speaker. Consequence. The hazard analysis may oversimplify the scenario, resulting in inaccurate causes or consequences being logged. This weakens the precision and effectiveness of the proposed mitigations. 3. Mentally preparing a response instead of listening. Oversight, focusing on formulating a reply or rebuttal while the other person is talking rather than listening fully. Consequence. Critical parts of the explanation are missed, leading to misunderstandings. Team synergy is reduced, and valid contributions may be dismissed or misapplied. 4. Ignoring inputs from quieter team members. Oversight, paying more attention to dominant voices and not giving equal focus to contributions from less vocal participants. Consequence. Valuable insights from quieter members, often with unique operational or technical knowledge, are overlooked, leaving gaps in hazard identification. 5. Not asking clarifying questions, oversight. Accepting unclear statements without probing for further detail or confirmation of understanding. Consequence, vague or ambiguous inputs remain in the discussion and may be recorded inaccurately in the HAZOP log. This can cause confusion and incorrect follow-up actions. 6. Allowing distractions during discussions. Oversight, checking phones, reading unrelated documents, or working on other tasks while others are speaking. Consequence, missing important hazard details or safeguard limitations that could alter the risk assessment. This also sends a signal to others that their input is undervalued, reducing engagement. 7. Failing to build on the ideas of others. Oversight, treating inputs as isolated contributions rather than using them as a springboard for further discussion or linking them to related points. Consequence, opportunities to deepen the hazard analysis or explore cross-discipline connections are missed, resulting in a less comprehensive review. Selective listening based on discipline bias oversight, giving more attention to inputs from one's own technical discipline while undervaluing other perspectives. Consequence, interdisciplinary hazards, often at the boundaries between systems, are overlooked, limiting the overall effectiveness of the HAZOP. 9. Not verifying understanding before moving on. Oversight, proceeding to the next point without summarizing or confirming that the group has a shared understanding of what was just said. Consequence, misinterpretations may persist through the rest of the analysis, affecting multiple entries in the log and weakening the integrity of recommendations. 10. Failing to recognize nonverbal cues. Oversight, ignoring signs of uncertainty, disagreement, or hesitation from the speaker that indicate a point needs more discussion. Consequence, potentially important concerns remain unspoken and the hazard review moves forward without fully exploring all relevant risks. This can lead to missed or underestimated hazards. Open-mindedness, 10 common oversights and their consequences during the workshop process. Rejecting ideas without exploration. Oversight, dismissing a suggestion outright because it challenges established design choices, operating practices, or personal experience. Consequence, potential hazards or innovative solutions are disregarded prematurely, leading to missed opportunities for improvement and a narrower scope of hazard identification. 2. Defending assumptions instead of testing them. Oversight, treating baseline design or operational assumptions as untouchable rather than subjecting them to the same scrutiny as other inputs. Consequence, embedded flaws in the design logic may remain hidden, allowing systemic weaknesses to persist into operation and increasing long-term risk. 3. Relying solely on past experience. Oversight, assuming that because a process or safeguard worked in a previous facility, it will automatically work in the current design without reevaluation. Consequence, context-specific differences such as feedstock variability, climate, or integration with other systems may be overlooked, leading to false confidence in safeguards. 4. Resisting cross-discipline input oversight, showing reluctance to accept suggestions from outside one's own technical discipline, assuming those inputs are less valid. Consequence, interdisciplinary hazards, especially at system boundaries, may not be fully explored, resulting in incomplete or unbalanced hazard coverage. 5. Failing to encourage alternative scenarios. Oversight, not inviting the team to explore what-if situations beyond the obvious or most likely deviations. Consequence, less probable but high-consequence hazards remain unidentified, reducing the robustness of the hazard review and potentially undermining resilience planning. 6. Overvaluing the status quo. Oversight assuming that existing designs, procedures, or safeguards must be sufficient simply because they have not yet failed. Consequence, latent conditions and dormant hazards may remain unchallenged, only to emerge during abnormal conditions or long-term degradation of systems. 7. Not recognizing the value of unconventional thinking. Oversight, disregarding ideas that seem unusual, complex, or outside standard practice without evaluating their merits. Consequence, creative risk reduction measures that could add significant safety or operability benefits may never be considered, limiting innovation. 8. Becoming emotionally attached to design decisions. Oversight, viewing challenges to the design as personal criticism, leading to defensive behavior rather than an objective review. Consequence, team members may avoid questioning certain areas, leaving hazards unexamined and eroding the culture of open collaboration. 9. Failing to adapt to new information, oversight. Continuing with initial conclusions even when new data or evidence during the HAZOP contradicts earlier assumptions. Consequence: recommendations may be based on outdated or inaccurate premises, reducing their effectiveness and potentially introducing new risks. 10. Ignoring emerging industry practices, oversight. Discounting improvements or lessons learned from similar projects or incidents in the wider industry because they differ from the current approach. Consequence: the facility may miss out on proven safeguards or smarter design choices, leaving it more vulnerable to hazards already addressed elsewhere. Concise communication: 10 common oversights and their consequences during the workshop process. 1. Overloading explanations with unnecessary detail. Oversight: providing lengthy, overly technical descriptions when a concise summary would suffice, often to demonstrate expertise. Consequence: listeners lose focus and miss the key point, increasing the likelihood of misinterpretation. This can slow workshop progress and contribute to team fatigue, reducing the quality of later discussions. 2. Using ambiguous or vague language oversight, describing hazards, safeguards, or recommendations in unclear terms that can be interpreted in multiple ways. Consequence: different team members may walk away with different understandings of the same point, leading to inconsistent follow-up actions and potential implementation errors. 3. Failing to structure information logically. Oversight: presenting points in a disorganized order, jumping between causes, consequences, and safeguards without clear separation. Consequence: the listener must work harder to piece together the meaning, which increases the risk of losing critical details and misrecording them in the HAZOP log. 4. Overuse of technical jargon without explanation. Oversight: assuming all participants are familiar with specialist terms, acronyms, or vendor-specific terminology. Consequence: non-specialists may miss or misinterpret important aspects, leading to incomplete or inaccurate hazard identification and reduced engagement from the broader team. 5. Not summarizing key points. Oversight: delivering information but failing to restate the main message in a concise, digestible form at the end. Consequence: the essential conclusion may be buried in detail, leaving the team unclear on the main takeaway and leading to diluted or incorrect recommendations. 6. Talking over other participants. Oversight: speaking at the same time as others or interrupting, causing fragmented information exchange. Consequence: critical pieces of input may be lost or missed entirely, resulting in incomplete hazard records and reduced collaborative efficiency. 7. Not tailoring communication to the audience. Oversight: using a level of technical depth inappropriate for the group, either too advanced or too simplified. Consequence: participants may either disengage due to lack of relevance or struggle to grasp the core message, both of which undermine the hazard review process. 8. Failing to highlight decision points. Oversight: presenting long discussions without clearly identifying when a conclusion or decision is required from the team. Consequence: decisions may be left ambiguous, resulting in unclear ownership for follow-up actions and possible duplication of effort later. 9. Neglecting visual aids, when they would help oversight, explaining complex scenarios verbally without referring to diagrams, drawings, or schematics that could clarify the point. Consequence: listeners may visualize the issue differently, leading to inconsistent understanding and potential errors in recording or follow-up actions. 10. Not controlling pace and volume. Oversight: speaking too quickly, too softly, or without pausing for comprehension checks. Consequence: key details may be missed or misunderstood, forcing later clarification and slowing the workshop. This can also create frustration and disengagement among participants. Respect for structure: 10 common oversights and their consequences during the workshop process. 1. Skipping or rushing guide word application. Oversight: not methodically applying every guide word to each process parameter, either to save time or because it seems repetitive. Consequence: certain hazards may never be considered, leaving unassessed risks in the system. This compromises the thoroughness of the HAZOP and can create dangerous blind spots. 2. Allowing discussions to drift off topic. Oversight: letting side conversations, unrelated design debates, or personal anecdotes interrupt the structured deviation, AHA's consequence, safeguard, action flow. Consequence: Valuable time is lost and key elements may not be covered. The team risks running out of time before completing the intended scope, forcing important sections to be rushed or skipped. 3. Failing to log decisions in real-time oversight, waiting until later to record decisions instead of documenting them as they are agreed upon. Consequence: details can be forgotten or altered unintentionally, leading to incomplete or inaccurate records that cannot withstand later review or audit scrutiny. 4. Not reviewing each parameter in sequence. Oversight: jumping between parameters or process elements instead of following a consistent order. Consequence: the analysis becomes fragmented, increasing the risk of duplication, omission, or inconsistent depth of review across sections. 5. Ignoring the agreed agenda and time allocation oversight, spending too long on certain topics without adjusting to ensure full agenda coverage. Consequence: critical items may be left for later sessions that never happen or addressed in a rushed, superficial way, reducing the completeness of the study. 6. Not verifying closure of each discussion point oversight, moving on before confirming that the team agrees on the outcome, action, and rationale for each deviation reviewed. Consequence: unfinished discussions lead to uncertainty in the log sheet, requiring rework or clarification later, which slows follow-up and can weaken action quality. 7. Failing to enforce documentation consistency. Oversight: allowing inconsistent terminology, numbering, or formatting in the HAZOP log. Consequence: post-study reviews become confusing, and cross-referencing between process elements is more difficult. This can lead to overlooked actions or misinterpretation of findings. 8. Overlooking progress, tracking against scope oversight. Not periodically checking which parts of the PNIDs or systems have been completed. Consequence: the team may accidentally duplicate effort on already reviewed sections or miss sections entirely, reducing the efficiency and coverage of the HAZOP. 9. Letting external pressures disrupt methodical flow. Oversight: adjusting the order of review or skipping steps due to external scheduling demands or late arriving participants. Consequence: the process loses its systematic nature, which increases the chance of missing hazards and reduces confidence in the overall integrity of the analysis. 10. Not reinforcing discipline when structure slips. Oversight: failing to step in when the group repeatedly deviates from the agreed process or agenda. Consequence: the workshop can devolve into unstructured discussion, eroding productivity, and leaving gaps in the hazard review that may never be filled.